In this problem, a picture with information and a graph are provided for the interpretation of this problem, and there are a couple of questions here related to this scenario, and looks like is related to kinematics or motion type of problem. So I'm gonna go with details on how to solve this one. So let me start with the picture. It says that a girl stands at the top of a cliff and throws a ball vertically upward with an initial speed of 12 meters per second. And that also says that at the time that the girl throws the ball, her hand is at height h. This is her hand, is at height h above the horizontal ground at the base of this cliff. The variation with time t of the speed v of the ball is shown in this graph. So we are going to work on the graph later, but now let's identify the motion that is going on here in this problem. So here we have three basically types of motion. One is a vertical upright. The two is vertical downward up to her hand level. And the third one is also vertical downward, but from her hand level to the ground. Setting up the Stuva table, the only information that is provided initially is the speed, the throwing speed, which is 12 meters per second. So that is the initial velocity. Let's complete this table with the ball going upward, up to this point right here. So this is ball going up. So that's our initial velocity. Our final velocity, when it gets right here, is going to stop and change direction. So this will be 0. Since it's going, the acceleration of gravity is downward, so because in opposite direction, so let's consider this negative 9.8 meters per second square. Also, we can think that is decelerating, because as is going up, is going to lose speed. So another reason why is the acceleration is negative. So this is all that we have for now. And then we have to look the graph. And the graph says that this is the behavior of the graph. I'm going to explain in a minute with more details. But first, I want to look what is the first question related to this problem. Okay, so in the next page, we have a kind note here, which says that speed in the upward directions are shown as being positive, and speeds in the downward directions are negative. To explain about the graph. Now, the first question is state the feature of the figure 3.2, which is this graph, that shows that the acceleration is constant. This graph shows that is a VT graph, velocity times graph. So the slope of a VT graph or gradient is the acceleration. So in this case, we have a straight line which indicates a constant acceleration, which means that it's the same at any point of this line. To calculate the slope or the acceleration, we need to pick some points on this graph and determine the rise and the run for the section. So to answer the question about to show the acceleration is constant, based on the explanation that I just provided, the slope of the graph is the same at any point, which shows the acceleration is constant. Now we need graphically, because here is referring to the graph. Graphically, we need to determine the time at which the ball reaches the maximum height and the time the ball hits the ground at the base of the cliff. So this graph shows the variation of the velocity of the ball over time. So initially it starts with 12 meters per second and will reach 0 meters per second when is right here. So what happened? The time that the velocity is going to be 0 is marked at this point. Each small square represents 0.1 seconds. So here is 1.1 seconds and 1.2 seconds. So the ball reaches the maximum height when the velocity is 0 at 1.2 seconds. Based on the description of this graph that says that is showing the velocity of the ball from the time that was thrown to the time that hits the base of the cliff. So that is the velocity that hits the ground, and this is the time that reaches the ground. So this is 4.1, 4.2, 4.3, and 4.4. So the time the ball reached the base of the cliff was 4.4 seconds. This is based on the graph. The next question is asking to determine the maximum height above the base of the cliff to which the ball rises. So on a velocity time graph, the area under the graph line is the distance. So a couple things we need to remember. The slope or gradient of a velocity time graph is the acceleration. However, the area under the line is the displacement. So we are using the area to find the height of the ball reaches after leave the girl's hand. Now the next question is asking to determine the maximum height above the base of the cliff to which the ball rises. So we need to determine the height from this point where the velocity is 0 up to when the ball hits the base of the cliff. Let's use this graph to determine the height. Since the velocity time graph, the area under the line or the area in this graph, we can calculate the distance or displacement. In this case, the height. So when we should kind of mark our beginning and end. So it should start right here where the velocity is 0, stop in the middle of the air all the way up, and end right here when hit the ground. Okay, so graphically these are our limits. So this blue right triangle, the base here is 4.4 minus 1.2, which is 3.2, and the height here, or the height of this triangle, is from 0 to 32. So that's 32. So let's see how we can use those numbers with our the area of a right triangle. The area under the line will be this one right here, which is symmetrical with this blue one. So even though we say that is the area under the line and this is kind of above the line, but we are using this because is symmetrical with a triangle that will be in this section. So the formula for the area of a right triangle is base times the height of the triangle divided by 2. So is the base is the timing, all right? So is 4.4 minus 1.2, which is 3.2. And the height of the triangle, that will be the velocity, which is 32, divided by 2. So that is the area, which is 51.2 meters, which means the ball drop from, this will be the 0, and this will be the base of the cliff. And this height, total height, is 51.2 meter and rounded to 51 meter. The last question. The ball has a mass of 250 grams and calculate the magnitude of the change in momentum of the ball between the time that it leaves the girl's hand to time t is equal 4 seconds. To approach this problem, we need to look what is provided. The mass of the ball, and is asking for the change in momentum and a time interval. We need to look what we have that we can integrate all those elements. The definition of force is the rate of change in momentum. So force is the change in momentum over time. So this is what rate means over time. If we do a kind of a cross multiplication here, the change in momentum is the force times time. The only force acting on the ball is its own weight. So the change in momentum is equal to Fg times time. Fg is mass times acceleration of gravity times time. Now we have all the components to solve this problem. So the mass is, instead of using 250 grams, we are using 0.25 kilograms because we need to have consistency with the units. The acceleration of gravity is meters per second square and second square, and this is second, so this must be in kilos. So when you multiply all this, so the change in momentum is equal to 9.8 Newton seconds. And why Newton seconds? Because the unit for force is Newton and the unit for times is second, Newton seconds. So that is 9.8 Newton seconds. 3 marks.